Hey class, we're on section 3 now. This has a lot in it, but fortunately you've seen a lot of it before. We're talking about zeros, and for the most part these notes do a great job, but don't forget about the complex numbers, the imaginary numbers. Just because it says no zeros, these are specifically, this right here is talking about numbers that, zeros that are real. We know that there's going to be exactly the same number of zeros as the degree of the function. We know that because I've told you that, and we could find the ones that we can't see by using some pretty creative mathematics. So when it goes through here and says, well, maybe there's no zeros at all, that's not true. Unless it is a horizontal line, that would have no zeros. But the idea is, if the degree is 4, there's going to be 4 zeros. Well, what happens if it doesn't look like that? And again, it could be that they are imaginary, but it also could be that there's an issue of multiplicity. And I want to show you what that looks like by jumping down here to this idea of multiplicity. A graph can pass through the x-axis or touch the x-axis. And I think the notes here say bounce, but I'm not going to remember bounce. I've always called it as touching the x-axis. So for instance, I've graphed a couple of things here for you. In fact, I've graphed these two right here with my Desmos screen. I had to adjust the window quite a bit for this one because they don't actually tell you to graph it, but I wanted to graph it to show you. And first of all, what's the degree of this? This is an x squared times x cubed. That is a degree of 1, 2, 3, 4, 5, 6. It's a degree of 6. So there should be 6 zeros that we see. Well, what does it look like? Well, it ends up looking like this. You notice the scale is pretty wacky. It goes from -10 to +10 in the x-axis, but -20,000 to 40,000 in the y-axis. So I played with it a little bit. But you can see that there is 1, 2, 3 zeros, just 3. But this one touches the x-axis. This passes through kind of normally, but this one just does kind of a weird whoopee thing, almost as if it were a cubic graph right here. And that is an important thing. So what we find out is that this zero right here, because it touches, it must be even. Because this passes through and this passes through, it must be odd. Let's go back and look at our notes for this one. And what we see is that the zero of -7 has a multiplicity of 2. Do you see that right there? This x plus 7 factor solves to be -7, and it's like a parabola. So it touches or bounces, as the notes have. This of -1/2, or as Desmos showed is 0.5, comes from this one. It's a multiplicity of 1 because there is no exponent on that factor, so it just passes through. And then this factor gives a 0 of 4, but it has a multiplicity of 3. So it goes through like a cubic. It passes through kind of like a cubic. So now, what is our multiplicity? 1, 2, 3, 4, 5, 6. It is 6. Does that match our overall degree? Yes, it does. Are there any of these zeros in the imaginary world? No, they're not, because we can see all of them as long as we include the possibility of those being a multiplicity of them. So let's graph this one real quickly, x to the 4th minus, etc. And if I graph this one, what I can see is, well, it looks like there is a 0 here, here, and here. Looks like there are 3 of them, but wasn't my overall degree something to the 4th? So how can I only have 3 if my degree is to the 4th? Well, you can see this one right here just touches like a parabola. The 0 touches as a parabola. So let's jump back to this and see if we could almost factor this. I'm going to notice that there is an x squared. X squared times x squared times minus 2x times minus 4, minus 8. And now I can say, oh, you know, are there numbers that multiply to be 8 and subtract to be 2? Sure are. 4 and 2. The 4 gets to be the negative. And now look at that. I've got a 0 of 0 with a multiplicity of 2. So it touches. I have a 0 of 4, but only 1, multiplicity of 1, so it passes through. And a 0 of negative 2, multiplicity of 1, that is, again, another pass through. What about number 8? What if it says there's a function that has this kind of thing? Can you create it? Sure can. It says a polynomial function has a 0 at negative 6. Well, that means it must be a factor of x plus 6. But it has a multiplicity of 2. That means there must be 2 of them. It's got another 0 of 2. Well, that means it must have a factor of x minus 2. And it has a multiplicity of 1. So there's just 1. That is my polynomial in not quite standard form. Standard form would mean that I would need to FOIL this out and distribute like we learned in a previous section. I will let the notes finish from there. And I think that is all there is to it as I look at these notes. Yep, so we're probably pretty good. If you have any questions, make sure that you let me know. Send me a text, send me an email, or let's talk during those Google Meets.